Okay, so let me repeat what I just said. So there are two kind of activity. One is related to create that particular object. And if you want to do that, you need to provide all the parameter in order for you to do that. But the other kind of activity is just accessing the object while the object has already been created by the appropriate ownership. Okay, I mean, the things so far we have been doing, I talk about shadow object, I only talk about the second part, not talk about the first part. So which means, for example, I use the example of Wall Street. The banker create an account for you, and that is a real object that has all your information. That's actually financially, they created, the banker created for you in Wall Street. While I merely want to create a shadow using the right credential, I can actually access to that. So far, you can see that when I say I only want to create with this 4 parameter, I'm really talking about only the second part. I assume somebody else is already created. So this separation also has fulfilled a requirement for encapsulation. So encapsulation is essentially saying that if I merely want to use the object, I shouldn't need to know the detail about the object. So that's why you have a public interface to allow people to do that. So far, the constructor is always in the public interface. That's why anybody can construct that. But shadow object further separate that out because, for example, there is certain information constructed, you need to know a lot of information. But as an outsider, you want to access the information from remote, you might not need to know the detail. I mean, for example, if you want to construct a person object, if my job is just want to contact with that person, I don't need to create that person. For example, that person is a Facebook account. So I just merely need to construct a shadow of this Facebook user locally so I can interact with, but the real account was created by the appropriate ownership. That's the scenario we're talking about. Is
So
that,
like
is that
using
clear?
your
Yeah,
so like
go ahead.
using your Wall Street example, are you
Mm-hmm.
basically making the claim that like if someone who works in Wall Street on their account information has their name and their social security, for example, and you're
Mm.
working remotely, that since you can identify them by only their name, that you don't want to risk accessing their social security when you wouldn't technically need it to identify who they are?
Yes, that's a good example, Jason. Yeah,
Okay, thank you.
yeah, you're welcome.
I have a follow-up question about that as it pertains to the homework.
Mm-hmm.
When you're looking at part 2, where you're creating kind of a shadow person, as you described in your video this morning,
Mm-hmm.
when you're actually calling that shadow constructor, uh, I noticed that when you kind of made your flight constructor, that part of the definition is you put like transaction, and then you built like transaction into the flight constructor, if that makes sense, and then you added the protected variables onto the end, and that's how you kind of made the constructor for flight. Is that
Yes.
the kind of situation we're going to have to do for person, but the added variables are going to be kind of the URL and the object ID? How do
Right.
you expect us to combine the information in like the internet sense, but also in the person object in order to contact the server?
Okay. So the scenario described is actually in the is actually a C++ way of doing the constructor when we have inheritance. Okay, I'm going to share my screen now to show you the code. Okay. Okay. So let me actually. So you're talking about transaction.h. Okay, so first thing that we should know that, so transaction, okay, so this is transaction. Transaction is part of the core. And transaction has a bunch of constructor. And then we have what we call flight, which is a inherit from a transaction. So when you have this inheritance relationship, it means that when you construct the fly object, that you also need to invoke the constructor for your parent class as well. So I think you're talking about this piece of code. If I may I show this part to you? Okay, let me move that here a little bit. Yeah, I think you're referring to this piece of code. Oh, this is messy. Okay, now I saw that. Let me actually see if I can make it a little bit prettier. Okay, now it's probably better. At least I don't go across the line. So this is the piece of code you're talking about, right?
I'm looking at the bottom piece more than I'm looking at the top piece.
This piece, right?
No, below that.
This piece.
Yeah, right there.
Okay, all right.
I was kind of trying to go off of that because the top just seemed too crowded for me.
Right. yeah, that's okay. Okay, so they are both constructor. Okay, so the fly has at least this two constructor. Okay, and let me. I mean, that's a good point. That let's look at the less crowded piece first. Okay, so this is the constructor, the what we call the function prototype for the constructor, which means that it takes 4 arguments into this. And because fly is also a transaction, that's why the notation when you have a colon, this means that it's going to call the constructor of your parents, this part. Okay, this part is going to call the constructor of the parent class, which is a transaction. Okay, that's why that, and it's similar here that I now, if I can do that, so the fly, this part is the original complicated constructor of flight. It's also calling the parent constructor here. Okay, the way to parse it like that. So it's always, because I want to construct myself, if you think about the fly, really a part of the real fly is actually a transaction. So you need to initialize that part as well. That's why you need to call that function. So that's what is happening, everything. So let's actually go back to the similarity for transaction as well, because transaction inherit from core. So when you call one of the constructor from transaction, for example, it's actually going to call core. So this part is calling the parent transaction constructor. So it's actually recursively, you call transaction is going to call core. So all the hierarchy, let me bring the hierarchy that this is, I don't like this. How do I get to that part? Yeah, see, it's always, I just want to open the window. It doesn't allow me. So that reminds me, I haven't uploaded my slide for a while, but okay, let me show you that. So this is the last slide that we talked about. So that's why when you have this hierarchy, essentially, when you construct a fly object, you need to recursively invoke the constructor of the transaction, which recursively invoke the core. And when core has nothing from the parent side, there is no parent, it's the root of the hierarchy, then it will execute the transaction constructor part, and then execute the fly constructor part. So similarly okay, go ahead.
I'm sorry. So like going over to the other branch, I'm following you on the right, but on shadow person, for example,
right.
How much arguments, I guess is the right word, do you have to plug in when you're defining shadow person? Like to actually be able to call the person constructor in shadow person's constructor, because I'm struggling with entering so little information that it actually makes having a server useful, and then just creating a shadow person that's basically a person that can also connect to the internet, if that makes sense.
Sure, sure. The way I see it, I didn't define the shadow person, but I would like to use the example of a shadow fly because
For
the
sure.
relationship between shadow fly and fly should be similar to here. So because shadow is really provide you just enough information for you to get remote to access the real. So the information you need to pass on to the shadow fly should be minimal. So that's why the design of the constructor of the shadow fly, it only has this 4 pieces of information in the core. In fact, I designed the shadow fly, which I think it will be the same thing for a shadow person, is enough information you can pass through the hierarchy such that you can have this 4 argument, because this describe when you create a shadow, you have to tell me where to find the real thing, right? The URL, VSID, class ID, object ID. So let me,
So for
go ahead.
object ID in specific, for the person, that object
Mhm.
ID, because it's not defined for us, could we make that the name? Or would it be better if we make that object ID like 0005 or whatever
Right.
to go and count
Okay.
with what you have?
So this is your choice. I didn't mandate you to do one way or the other because you're going to develop both the client side and the server side. So because it's on the server, which means the real location where it's receiving your remote call, and that particular place, they are going to matching, right? They have the pointer, they have to create the real say person object. And then you can give whatever ID you want to assign as long as the server code it need to match. So let me show you my example. This is the part that, of course, there's a more general way to deal with that. Sometimes you have a registry or something like that. But let me show you an example how I did that to show you that you can do the same thing as well. If you go to HW3 server.cpp, so here's what I did. You see that I'm just basically matching when the call from RPC is calling into this routine, which I can start to mess up with. And basically what I did, I just look at, object ID is equal to 002. If this is equal to 002, I'm going to relay that to F2. So you decide the scheme on that. So remember, now you can modify the code in both client side and the server side. And therefore you assign how you want to map the ID as a argument to match with a local reference of the object. And then you issue that call.
Okay. As for the second part, when you say, what does it say? Check if 2 person objects are identical. Does that mean I'm taking a shadow object equal, and then a person object I have created locally on my machine, or 2 shadow objects equal to each other? How do I show that I've coded it correctly? Like, what's my test?
Okay, the way you test is that if, okay, we go back to um, um, the the client side. Okay, at the client side, if you compare, let me use my slide to show what I'm talking about. Okay, so at the client side, right? This is at the client side. You're actually going to call a function operator equal, right? And oh, I know what example I want to use. This is probably a better example. Okay, this is a piece of code that's we already implement in the one of the member function.
Person.cpp.
Right,
Yeah.
right. Person.c. But this could be in anywhere in the application code as well when you have operator equal between 2 objects, right? So when you call this object, that there are 3 cases in fact, 3 or 4 cases you need to worry about. Okay, So because here you want to implement, not only you implement this operator, but you also worry about this two object. They are both person object, right? This is a person object and a person is a person object as well. So both of them could be local. If both of them are local, great, you just get your code done, that's fine. But could be one of them are remote. For example, in this case, maybe this is local. If you can get to this point, usually this is already local. And then a person is remote, which means a person is actually a shadow object. So the real a person is somewhere else in outside in another server or somewhere that on the internet. And therefore, for you to actually really test your code, that you have to construct the object. For example, if I were you, I will actually construct, assuming I just want to compare two person. So I'm actually going to do first, put both. So we're talking about two things. One is where is the location of the person object one? Where is the location of person object two? And where's the location when I make the call of the operator equal equal? So I think in the worst case, you need 3 hosts. So you call the operator equal equal from host number 1. But this, the object that's actually going to really the one on the left side of the equal equal operator is actually going to be on machine number 2. And then a person is on machine number 3. So you can see that you're calling from machine 1.
3
and
machines?
Then, right, you have 3 machines, which means that, for example, you use 3 CSIF machine, or the other thing you can also do that is using 3 processes on the same machine. That would be fine, but there are 3 different programs. You can do that. Just like you can test my program, both of them on the same machine, right? You can actually create 3 different processes, 3 different programs.
Do you have to define the port differently for a second server then?
Yes, exactly.
Okay.
Yeah,
and that leads into my next question is I noticed that in your homework part 2, you say we have to make a Johnson file to define the interface between the client and the server. Can you explain where the instructions or guidelines for that is?
So if you look at the, okay, there are 2 different issues. The port number and the port number and the URL is independence of the JSON file. The JSON is just represent the format you're going to exchange. Okay, so let me get through first the port number issue first, and then we get to the JSON file.
Gotcha.
For the port number, if you go to HW3 client, the CPP, is that right? No, I actually didn't put it here. Bad, that's my bad. Okay, I put in, I kind of hard coded for this one. But you don't have to do like the bad practice I'm doing. So I actually embedded into Shadowfly. So inside Shadowfly, no, I didn't put it here. Where I put it? Where did I put it? Oh, I know what I, where did I put that one? Let me look my own code. Oh, okay, I'm sorry. I put it in, I did put it in the client.cpp. Okay, so you see that when I call the shadow, I have this URL. I have this URL with a port number. So this part is the URL, and this part is the port number. So indeed, you can do this using the HTTP, which you can just have the URL column with a port number, and then it will contact the right server. So this is from the client side, I actually define the port number here. And from the server side, this is what I did. From the server side, blah, 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 where did I do this? You see here, I'm actually using the same port number here. So basically,
if
this is
I
your
made,
control.
if you put two Homework 3 servers, but you just changed that one number, and then they had like different people, like how you have Lion King, Lion Queen, if you put like Lion Prince and Princess on the other server, you
Yeah,
could technically,
right,
okay.
exactly. And you can have a multiple server. You can have in the same program, you have multiple server listening to different ports at the same time as well. So port number really controls you not confusing. So I can tell you that if you run two programs sharing the same port number, both of them are server, one of them will not be able to get. So that's why you need to make sure that you assign different port number to do that. Yeah.
And how do you make that Johnson file?
Okay, I'm going to show you the JSON file here. So this is a JSON file. It's in the directory. I show you an example. Okay, so this is the when you define that this is for one function. So the function name is called ECF36B HW3. So this is the function I'm going to call between the client server in RPC. And inside this function, I have to say, well, when I call this function, what information I need to pass. And this is the information I can pass. So you can think about this is just a handshake or communication protocol between client and server to say, hey, I have this function I'd like to create called ECF36B HW3. And this I showed this part in the demo on Tuesday that you can change this name. If you change the name, you're changing the name of the function. For example, here I'm using get ECF36B HW3. For homework assignment number 3, you probably don't want to use this. You can change the ECF36B to say get distance, and then you have a one block of this for one function call. But because we need to implement another one, so you're actually going to add another one, say call operator equal, another one for conflict of interest, and another one for something else, whatever. So you can have multiple of this. You don't have to have one. So this is just saying that what is the information format for parameter? Parameter means that from client to the server side, and return is from the server side to the client side. And by the way, the JSON file, everything on the right-hand side of this column, you can declare that. Those are just example value. And the JSON stub really only look at the left-hand side to provide you all the parameter like this. Because here I have a parameter action, owner VSID, host URL, class ID, object ID, arguments. Because you have this, so the code it construct will have this as a parameter. So let me just show you this as an example to open another window. Let me show you what do I mean by this. This is a JSON. And now if you go to, let me see, this should be in.
Is it the thing you build in server?
Yes.
Like when you're sending it back?
Yeah, that's what
Okay.
I built in server, but it was actually included in either HW3 server.cpp or H. Let me check, okay? Yeah, it is in server CPP. You see that this part of the code. This part of the code was the server part. It has 1, 2, 3, 4, 5, 6. It match what you have with this, but in a different order. So you look at this is action, owner VSID, host URL, class ID, object ID, arguments. That match 6 of them. That match 1, 2, 3, 4, 5, 6. But the orders are different. The order are different is not because of me, because of the JSON RPC stub program. It take that JSON string it automatically generate for this order. I guess they're using alphabetic order. You look at this, they actually do alphabetic order, which is okay, fine. Yeah, I just noticed that it's alphabetic order about the name I specify here.
So if you have, let's say you get distance call and then you have your operator equal call, does that mean that in that Johnson file you need to show two different gives
Yes.
and two different responses?
Yes,
Okay.
exactly. So let me show you. This is exactly the part one I like you to do. Let me actually go to the part one. So in the part one, remember you're playing with the spec.json, right? Spec.json, if you look at that, he has a first name, first one, which is to say hello. The second one is just notify server. And the third one was add number. And the fourth one is add number 2. And then he has another function called calculate. So they define a lot of different functions for this. And so that's why when some of you when you compile, you cannot get, say, calculate is not there, and then I realize, okay, I must be giving the wrong JSON file, which doesn't have this function. If you have this segment, it will work. Yeah.
All right, last question.
Sure.
I promise.
No problem. You're very welcome. You can ask another 70 questions. I don't think everybody will appreciate. Your question is not just help you, it help everybody else as well. I appreciate it.
Thank you. The part 3. So moving on from the equal person in the COI situation, I was tempted to just put virtual all the way through on the conflict of interest that was already defined. And I was able to make it so my Johnson kind of returned a thing on top of get distance that said under successful conflict of interest ? 1 or 0. That, and then I asked you about it on Piazza, and it sounded like that's not what you were looking for. Can you clarify like exactly what it would look like when I get it right, kind of thing, if that makes sense?
Look at my Piazza. I think I answered some of that question, but I'm not sure I answered it correctly. Let me try to go to Piazza. Where's my Piazza? Okay. If you don't mind, can I show the? I guess this is public information.
Go for
right?
it. Go for it. Yeah.
Is this one yours? No. This
No.
one, no.
I think I'm homework 3 clarification.
Yeah, this one.
Yeah.
Okay. Let me actually. Let me see what you have here. So you're talking about this part, right?
Yeah.
Okay. Let me reread more carefully. Just fly my.
It's in greater detail in your response because we went back and forth a little bit.
Yeah, I guess I'm more respond to. I think I'm more response to maybe I either one I misunderstood that what I was response. Okay. By the way, I don't think we need. So my response, maybe I should modify. I don't think you need. Do you need shadow transaction?
I've been trying to figure out how you need shadow transaction for like the last hour.
You don't need shadow
Okay.
transaction because shadow Shadowfly already can access the information about the transaction. Is that right? Shadowfly. Yeah, I think I was wrong. I'm sorry that I don't think you need shadow transaction. Shadow person and shadow fly should be sufficient. So I will update my response to you. And now I'm trying to look at your part 3. This is return the boolean within the JSON from part 1. Okay, fine. But do I need to print out the value specific, like a distance is printing out? Okay, the printing part is your option. It's really, I'm printing out is just because to demonstrate I'm getting the right value. So here is your choice about how do you show it to yourself and show it to the TA that how you get the result correctly. And that's all you need. As long as you can show that, I don't restrict you about, you know, how you're going to accomplish that. Okay.
And so if you like, essentially in my Shadowfly class, I added on like conflict of interest bool, and then I went and defined it in .cpp of that. So
Right,
from that, is that essentially what you were looking for?
yes, that's what we're looking
Okay.
for. But either at the HW3 client.cpp, you're going to call that, you print that line to say, okay, I got a return value bool
Right.
says
Okay.
it's true. Okay, yeah, that's fine. That sounds good. I mean,
Thank
sorry
you.
about yeah, this definitely, I don't think you need to have a shadow transaction. Yeah.
Hi.
Yes, please go ahead.
So a few days ago, you said CSIF machines are good for homework 3.
Right.
And I'm assuming that meant when we downloaded the GitHub package, it asked you for a password when you enter the commands that you told us to.
Okay.
And I entered my password
No,
and it
no,
says,
you cannot do that. Sorry.
oh,
I didn't clarify correctly. Let me bring my, can you still see my screen? Hello?
yeah, I can see your screen. Yeah.
Okay.
Yeah.
Okay. I want to tell you what I meant by that. And I'll explain to everybody. This is a good question. I just didn't bother to explain all the detail when I say that. I just want to quickly tell you that it's available. But here is what I want to really tell you related to your question, and which you receive that your password won't work for that is absolutely normal. Okay, and that's expected. So what happened is that if you're going to run on your own machine, then you essentially need to install all this package in order to get it available for your programming. And the thing is that in order to do the install, we actually use this command called sudo. So sudo is a command that you run the command after this as a super user. As a super user, as a privileged user. So if you're doing this on your own computer, yeah, you're the super user because you own that computer, so you can do that. That's no problem. But CSIF is a facility shared by all the students, so therefore, we, not just you, but including myself, I don't have the super user privilege to do anything on that. So that's why initially I said, no, we cannot do this homework on CSIF machine because we cannot run this command because it requires super user privilege. So instead what I did is I contacted the CSIF folk. I said, wait a minute, I cannot do this, but can you actually do all this for all the student and me? And they said yes. So that's why they spend time to install all this for us. So if you're using CSIF machine, you can just neglect the installation package itself because they have already installed it and I tested and it actually worked. So that's why you got that message, because when you try to run the command, they ask password. They're not looking for your password. They're looking for the administrator's password for CSIF. So that's why. But after that, you still should follow the step 1, 2, 3, 4 here to actually test it, to make sure that environment is okay. And so that gets you familiar with the part 1. So if you use CSIF, let me just summarize. You started from here. Okay, you started from here, but anything? Oh, sorry.
Okay, so I don't need to download anything. I can just start from step 1.
Exactly.
Okay, got it. Thank you.
Okay, you're welcome. Any other question? So let me.
Hi, Professor.
Yes, please.
Just to clarify, so we don't have to do any of the part 1, so we can directly start on the step 1, writing the JSON specification file?
Yes, you can directly start in here. But also, you can, what I said is you can either write your JSON file or you can just use this one. You can just directly click here, and then if you click here, you will get this JSON file that you can then download from here, the GitHub. Yeah. Okay. By the way,
and I had,
go ahead.
I had one more question. You said, it says like the instructor will also provide a short lecture to cover this topic. Is that part of the installation? So we don't need that thing anymore?
I don't think I provide a lecture on installation in greater detail. I think for part 1, I probably just showed the step 1, 2, 3, 4. I forgot exactly, but I didn't talk about the installation in detail because on different platforms, the installation are different. Yeah.
Thank you.
You're welcome. Yeah. Okay. One thing I should say. There are 2 things I should say related to your question. Number 1, for those of you who download the homework assignment document earlier, because I made a few changes, critical changes, after the initial release of the specification. Please download, make sure you have the newest version. Okay, number 1. Number 2, for the installation, if you want to build the environment on your own machine, regardless it's Mac OS or it's Ubuntu or WSL, I mentioned last night during the office hour, but I want to just show that again. If you look at the, let me see, where's my, if you look at the README, this is the document you receive. Maybe I should just directly go to the link. Okay, if you come here, if you look at the README document that included in the assignment, there are 2 parts of instruction that can build you the environment. The first part is just using what they call install the framework. And the second part is called build from source. So I want to tell you that unless you really have a lot of sys administration experience, or you really want to try it yourself, don't go for build from source, especially for most of us. We are not, we haven't done this before, and you will encounter a lot of challenges. I would just say, just follow, install the framework.
Because I don't want people to know me.
But you don't think they can recognize your voice? Like,
They probably can. Whatever. And so can
Okay.
Satoshi, I bet.
Okay.
Wait, did you meet Satoshi and them here? Or you
And
met
the
them in
summer
India?
starts. Satoshi's from Dubai.
Okay. Should I stop recording because this
It's
is
Middle
being
East.
recorded right now?
No.
She was born there?
Okay. Any other question?
Professor, where can we find the updated doc for homework 3?
Say it again. Sorry, I missed part of your sentence, Aldo.
Where can we find the updated document for homework 2?
Homework 3 is
Oh yeah, homework 3 updated.
always in the class folder.
Okay.
So in the class folder, you can see that this is the folder on Cyrus, which is in the FAQ document. If you miss this URL, let me know. I will send to you. So I just keep updating this. You can see that on my screen. The last time I updated this document was about 2 days ago. Okay. So you click this one. This is the timestamp when I last modified the assignment. So you just click here, you can get the newest one. So I always put the newest stuff, including the homework assignment or PowerPoint slides in this folder. Okay, and every other thing will point into this. And also you can see that the tar file are also here as well. And I put spec.json here as well. Yeah.
Hi, Professor. Can you talk about the slideshow for lecture 6? I believe it's page 21.
And sorry, which PowerPoint file? Lecture 6 or lecture?
For lecture 6.
Lecture 6, of course. So I'm sorry, I haven't uploaded the lecture 7. I will do that after the call. I just lecture 6. Okay. Slide 21. This one is
Yes.
this is the slide. Okay. Okay. Can you tell me that which part of this slide that you like me to clarify?
I want to know like the value ECS36B homework 3 was that thing, and then like value P that word in red.
You're talking about this JSON underscore value P, is that right?
Yes, and then the top one, like the value ECS36B homework 3.
Okay. I will tell you precisely what's happening. Okay, so let's actually start it with the JSON file. So so I have a JSON. This piece of code is following the JSON file we specify. So that's why I said if you want to do any modification, you try to modify the JSON itself. So have you noticed that inside the JSON file that I have a function that I define? The name of the function is ECS36B HW3. And then this function has 6 arguments, 6 parameters, right? And look at their name: action, owner ID, host URL, class ID. So when I specify this in JSON, that the JSON RPC stub program is going to produce a function prototype that the name match the function name here, and the argument is going to match the 6th name. Okay, so which means that now I go to the server, which is the one that being called by this function call. So that's, oh, sorry. This part was the client part, not the server part. Okay, I took it back. So this is the client part when I make a call to that function. So this part, by the way, this piece of code was generated by the JSON RPC stub program. So this, you don't write this code. This code was generated. And that's why this code have this function called ECF36B. And ECF36B HW3, this name, the red part here, they match the name that I define in the, I missed my slide. They match the name I define in the JSON file. And then I have 6 parameter, and then that's why here now you have 6 parameter: action, arguments, class ID, host ID, object ID, and owner VSID. That those 6 are the argument matching that JSON specification about those 6 arguments. Okay, so now I just give you the function prototype, right? And now I want to show you how I actually make that call. When I make that call, I'm actually using this slide here. So this is my show fly, get distance. In my implementation, you see I'm actually making a call. I create a my client, which is follow the HW3 client, and my client, and then I call that function that's being generated by JSON RPC stuff. And I put in 1, 2, 3, 4, 5, 6. I put in this 4 arguments to make that call. Okay, so now you see that what's the interface between my code from the client side connecting with generated code from the both at the client side. Are you with me so far?
Yes.
Okay.
So the green page is just the code generated by the JSON file.
Exactly.
And then everything in this green page is just a function. And
Right.
then the shadow object will call the function on this page.
Exactly, exactly. So since we're on this topic, because you asked the question about JSON value P, right? So JSON value P is, if you look at this, this is following the JSON framework, okay, the JSON processing, because the call about in the JSON file, we specify require 6 parameter, right? The 6 parameter: action, argument, class ID, host ID. What it does is it just shuffle the value you call. You provide this and put that into this JSON, JSON value P. This part of code is essentially just follow the JSON format. It's just putting whatever value you gave me, I put into the JSON value P. And after I finish the JSON value P, I just really call method. I just call this method, putting this P value and this function. It will now deliver to the server, and then it will give me the result. You see that result is also a JSON value.
Can you explain what's the P again?
Okay, P is a variable. P is a variable, and is the type of the variable is JSON value. So JSON is a library is using C++ to define, and one of the type or class actually is a class. It's called value, and within value it has all the so maybe we can take a look at this. I mean, I want to show you where it's defined it, okay? So if I go to /usr, include, do I have JSON on my platform? No, I don't have it. JSON RP, JSON CPP. No, it's actually not here. Where is my, where is my include file located?
So the JSON is just like the STD. It's a library.
Yeah, it's a library, but I want to show you that include file. I forgot in Mac where I can get it. Let me see, is this where? JSON/JSON.h. Whence? No, I need to find something else for me to do. I forgot the command to look for the file because it's actually inside this file. The JSON.h has a definition for the JSON column value, and which is a class which has all the detail about that code. On Ubuntu, I know where it is, but let me just go to my Ubuntu. Maybe it's easier. Or maybe I can go to the, I can go to PC02, PC2.cs. Okay, I'm showing you on the CSIF machine. Oh, what did I do wrong? What? That's very strange. Let me change another host. Okay, I'm in. Okay, here I have, oh, I don't have it here. JSON. Oh, JSON CPP, sorry. Yeah. So under this directory, if this is under the Ubuntu CSIF machine, go to US include JSON CPP/JSON. You have this JSON.h. Okay, and JSON.h include another file called value.h. And inside value.h, okay, here is the, this is just an enum. Wow, it's too much. Ah, here. Here is the value. This is the definition of the value that is under this under the JSON API. They actually have this. So everything we're talking about here, this is the public value. It's fairly complicated about why it has. Okay, and but it contains all the value, and that's the source about what the piece of code is based on. So most of us, we don't need to understand the detail about JSON value because it's quite complicated, but we need to know the basic about how to use this JSON value P to be able to construct passing the parameter here and there. Okay. Okay, any other question?
The action in quotation is just like the thing you have in JSON file, and then the thing on the right side is the parameter you put in, right?
Right, exactly. Right.
Okay, got it. Thank you. Yeah.
You're welcome. Okay, any other question? Sorry, I cannot hear you. Shreyas? Yeah, I only see Bill Clinton. Yeah, there's something about the voice. Shreyas, if you try to say something that didn't work, can you use chat so we can see your question? Let me actually see the chat. What do I have? Yes, yes. I think you need to have that. Strictly speaking, you can have it with just one entry and have let all the function using that same entry. But I think when you want to deal with function call with different type of argument, then it's better for you to create two different JSON entry. I mean, for example, we're talking about overloading and COI. One main difference between overloading and COI is that overloading is number one, overloading has parameter, has one parameter, and the COI doesn't need parameter. And number two, overloading is for the class person, and COI is for class flight. So they're different class, and also I think the main thing is the parameter that you need to provide.
What does the COI stand for?
Conflict of interest. So conflict of interest is the particular example I'm using in the homework assignment number 3, where you have let me just use my latest slide. So one second. No, not this one. Here. Okay, so this is the code in the both in transaction CPP and some of that in transaction.h. So flight, class flight is a transaction, inherit from transaction. And within transaction, they have a parameter called agent, tr_agent, which is a person. And in class fly, you have another person, which is FL passenger. So what we want to do a check about conflict of interest is saying that whether these two are the same person. I mean, the scenario is you can imagine is that you are representing your company as an agent to sell this airline ticket to another person, and that person is yourself. So you're selling things to yourself, which might be okay, but this is potentially for the company policy, they want to check whether this has been done differently. So that's why we have this check called conflict of interest, checking whether this two object, TR agent is the same person with a flight passenger.
Oh, I get it, because I haven't watched the video for lecture 7. Sorry about that.
That's okay, no problem. Yeah, I talk about this
Yeah.
a little bit during lecture number 7 as well.
Yeah.
Okay, you're welcome. Let me bring up my chat.
Professor?
Yes.
Can you explain why in some cases when you make a new class, you make it in an already existing CPP file, and then other times when we make a class, it might have its own CPP file, and what are the advantages and disadvantages of doing either or?
Yeah, okay. I can answer your question very, very simply. I was lazy and sloppy when I do that, okay? I should always have a separate file for each of the class and CPP and H. For example, I set the bad example that I put both fly and transaction within the same .h and .cpp file. I should split that into transaction.h and then fly.h, have a fly.h include the transaction.h. So it's just my laziness, yeah. So I set the bad example, yeah. So I intentionally did that such that I like you to ask me a question like this, okay?
Would shadowflight.cpp, would that work if it was still in the transaction flight, since it needs to be accessed from remotely? Would that still work the same way, or would there be issues in the case that we wouldn't have access to, if we didn't have access to?
It should work the same way. It should work the same way. Okay. It should, yeah. Everything, if you include everything in the same, I mean, all the class definition into one big file, it should still work. Because essentially just compiler is just including them, right? I mean, just for good habit, we should split, but technically the compiler doesn't care. Okay, any other question? Okay, while we're waiting, I just want to upload the PowerPoint file. I haven't uploaded the PowerPoint file, so okay, let me do this. Just quit this. Okay. No, sign. Okay, so the latest PowerPoint has been uploaded as well. Okay, so now let me just double check. Do I have everything here? Okay, yeah, it's just being uploaded. That's good. Okay, any other question? Okay, if you have any other question, you can ask on Piazza or email me, or otherwise you can just ask me tomorrow. I'm hoping to give you that small program, exercise program. I've been testing it. I think it's almost done. You will be able to start using your VSID to communicate with the server and then get that 20% of this course. Okay. All right. Thank you for coming today, and I'm going to stop recording.